Okay, so this video is for all those who had difficulties with section 3.3, the more max-min problems. I know I wasn't in class for one of them, so apologies for that, but here you get to listen to me on video instead. So I thought I'd take two examples from our AP Calculus textbook. I know you're not doing AP yet, but hopefully you will next year, and show you how we can actually do these two AP Calculus questions using our Math 11 skills. These are called max-min problems, and they're quite useful, and they come in quite handy when looking at different things in, I guess, real life. And so let's go and take a look at example number 1 right now. By the way, if you've read this already and you see speed, and you see time and distance, you're thinking, oh man, is this physics? And the answer is, we do lots of physics in calculus, so don't be afraid of that. This question talks about a boat leaving a certain dock at 2 p.m. and then it travels due south at a speed of 20 kilometers per hour. So imagine you being here, and I've got a boat that's now going 20 kilometers per hour down the road. Why can't I do this right now? Whoa, what just happened there? Let me go back up. Oh, here we go. So, boat, right, going due south at a speed of 20 kilometers per hour. So that's the dock. And it says here there's another boat that's heading due east. So I'm going to use my blue pen. I'm going to draw a boat heading due east, but it's actually to the west of the dock, and it's traveling towards the dock. And it says it reaches the dock at 3 p.m., so 1 hour later. The question we have for ourselves is, at what time were the two boats closest together? So if you imagine like the blue ship being here and the black one being down there, then the distance we're talking about is this diagonal distance here. Okay. Of course, that distance changes depending on where the boat is. So if I were to move the boat to this spot, and then this other one moves down here, then yes, that's the distance, and of course it's a little bit smaller. So the question is, well, at what time? So is it 2:30, 2:25, 2:19? At what time were the two boats closest together? Now, when I say closest together, what are we thinking here? Well, this is a maximum or minimum question, so I'm asking you for the minimum distance. Excuse me, still sick. Come on, all you physics people. What do you know about distance, speed, and time? Yes, distance, of course, equals to speed times time. So I guess the question now I have for you is, how do I describe the distance that each one of these boats has traveled? Let's take a look at the boat that goes south first. Okay, it's going 20 kilometers per hour as its speed. So what would the distance be in this case? D would be equal to speed, which is 20 times time. Now, do we know the time? No, we don't. Time is the one that varies in this case, so whenever things vary, we give it a variable. Let's use t. So I'll say now, note t is the time traveled by the boat. Okay. Let's do the distance for the blue boat. And if you said 15t, I'd be, that is cool. But I wouldn't say that's the correct answer. How come? Because if you did 15t, you are interpreting the boat starting at the dock and now moving east. But that's not the case here. The case is, this boat was already west of the dock an hour before, and now it's moving towards the dock. Now, an hour before, how far was it away from the dock? What is this distance? An hour before 3 p.m. Traveling 15 kilometers per hour, it must have been 15 kilometers to the left of the dock. So our distance would be 15t, and we have to then subtract 15 because our dock is like our initial value of distance here. So that's our initial origin, so to speak. Okay. So now you have an expression for distance going horizontally, one going vertically. And so the question I have for you is, how do I find the distance diagonally? If you said Pythagoras, you are correct. So we'll take 20t We'll square that. We'll take our 15t minus 15. We'll square that. And let's call this d squared, capital D. So that's our distance we're trying to find. Once again, let's go ahead and expand. So 400t squared. This is what? 225t squared. 15, 225 times 2 is 450. T plus 225, and that equals to d squared. I'm going to try to simplify and collect like terms. 625t squared minus 450t plus 225, that equals to d squared. That's d squared. So we want to find d. So yeah, we should be taking the square root. But if we take the square root, then we've lost our quadratic that's right in here. And that's a problem, because I don't know how to take or find the maximum of a square root function. But don't worry, there's a nice little trick we can use here. Excuse me. I want you to understand that minimizing d squared actually produces the same t value as if we were to minimize d by itself. Okay, so think about that. I'm thinking if I square something, it's still going to be bigger, but the minimum of d versus the minimum of d squared, the t value will be the same. Okay, so that's a little trick. And why is that trick helpful for us now? Because now we can just take our expression and now complete the square. Whenever we're asked to minimize or maximize, we need to complete the square. You guys know how to do this. We'll factor out the a value, 625. You get some nice decimals. That's not too bad. Oh, this is bad. 225 divided by 625. I think it's 1296. You double check your answer with mine. Oh no, what am I doing? I've already completed the square, right? Yeah, so 225. By the way, how did I get this? That's half of the 0.72. And then, of course, squaring the result. Don't forget, you multiply that by 625, so you have to subtract it out. Okay. And lo and behold, after completing the square, you'll get 625, t minus 0.36, all squared, and then this combines to get you 144. And that equals to d squared. Why is this important? Well, now we can find the vertex, and the vertex is 0.36, comma 144. And remember what I always say, you have to interpret the vertex. So what do these values represent? The 0.36 represents the t value, which is the time after 2 p.m. The 144 will be what you've actually maximized or minimized. In this case, it's a minimum because, yes, the a value here is positive. So it's the minimum of d squared, because that's my variable that I used. Not d, but d squared. So t, of course, is the time in hours. I guess I should convert that into minutes. So 0.36 times 60. That's about 21.6 minutes. So you can say that the time the two boats were closest to each other was at 2:22, I'll say. And what is the minimum distance? Well, remember, d squared is 144. So what's d? Yes, that's just 12. So the minimum distance, I'll say the minimum distance between them is 12 kilometers. Okay, so a few tricky things. I think the first tricky part is just coming up with this diagram up here with the boats. The second tricky part is figuring out how to calculate distance, which you need some physics. And the third tricky part here is finding this minus 15. Because we were 15 away from the dock, then we have to take away that 15. All right, and that's because it was 1 hour away. All right, I hope that makes more sense. Okay, we'll move on to the next one here. Similar triangles is something you should have seen before in grade 9 and grade 10. The idea here is that the corresponding angles, so angle R and angle C, are the same. The corresponding angles of Q and A are the same. And then P and B should be the same. Not only that, the ratio of the sides, of corresponding sides, so let me highlight A and Q, that ratio is the same as the ratio of B and P, and also the same as the ratio of the C and the R. And that's what this says over here. Okay. How is this going to help us out with this type of question? Well, example number 2 says, I want you to find the area of the largest rectangle that can be inscribed. That means it can be drawn inside a right triangle with legs of 3 and 4. And it says the two sides of the rectangle have to lie along the leg. So it has to actually touch the leg of the triangle. Okay? So, once again, you want to maximize or minimize something. You should always try to figure that out first. I think you want to maximize the area. So how do I calculate the area of the triangle? Not triangle, sorry. Rectangle. Length times width. That looks good. L times W. And if we do that, the question is, well, we have two variables on the right-hand side. Yuck. So what do we do to figure this out? There must be another equation or relationship between L and W. This is where the similar triangles come into play. Can you see two similar triangles? I see this one, and I also see this one in purple. Oops. Purple. Right? So if I were to draw the purple one here, and I draw the red one here, let's see if we can compare. The red one, we've got numbers 3 and 4. How about the purple one? We have this thing called W as the height. How do we describe the length here? If the whole thing is 4, and we're subtracting L, then this must be 4 minus L. So using the idea of the corresponding sides have the same ratio, W over 3 must equal to 4 minus L over 4. How is this going to help us out? We can cross multiply. And the goal is to solve for one of the variables. So 4W equals to 3 times 4 is 12 minus 3L. I'll solve for W. 12 divided by 4 is 3. 3 minus 3/4 L. Once again, why is this helpful? Hello, we can put this into our area equation. So area equals to length times width. And our width now is an expression that can be written using length. We'll distribute. And there's your equation for area. Right now, we haven't done anything to actually find the max or min, but we do have an equation for area, and it's in reference to its length. So at this point in time, to find the minimum or maximum, you guessed it, let's complete the square. By the way, do we have a min or max in this case? Your answer should be we have a min. Why? Because the a value is negative 3 over 4. Let's go ahead and try to now do the algebra. We'll factor out the 3/4, L squared. 3 divided by 3/4. Be careful here, people make mistakes. That's multiplying by the reciprocal, so it should be minus 4. Think of what magic number goes inside the bracket. Half of negative 4 is negative 2. Negative 2 squared is 4. Don't forget to balance it out. That will be an adding 3. And then we have here a equals to negative 3 over 4. L minus 2 all squared plus 3. There's our vertex form. Yay! We're not done yet. Let's calculate the actual vertex. How about 2, 3? And once again, I ask myself, what does this mean? The 2 represents the L. The 3 must be the area. This must be the minimum area. So I found the minimum area is 3 units, and the length, I guess it's 3 units squared. The length is 2, and how do I calculate the width? Well, you know this is rectangle, so you can just take the area divided by length, so 3 divided by 2. Or, if you want, you can just go ahead and use this equation that relates width and length, and just plug in 2 there. So 3 take away 3/4 times 2. So 3 take away 3/4 times 2. That's 3 times, or minus 3 over 2. I think that's just 3 over 2, or 1.5. How does that sound? Hopefully it makes more sense to you. Try those 2 questions underneath. try also the one on the practice quiz. And yes, you bet one of these two questions is probably going to be on your celebration of learning on Monday.